everyone. Today we are going to talk about something called a single displacement reaction. Now, in a single displacement reaction, you have one ionic compound. In our case, our ionic compound is going to be this stuff. It is called copper 2 sulfate. It is made out of a copper cation, so copper, which has a charge of +2, and a sulfate anion. Now, sulfate is not made of just sulfur. It is actually made of a sulfur bonded to 4 oxygens, and collectively that acts as a single anion. So that is another example of a polyatomic anion. And that sulfate anion, which I've done in red here, is bonded to the copper cation. Now, I also have this stuff. This is just steel wool, like you could buy at any hardware store. But importantly, it is made out of iron, which on the periodic table has the symbol Fe. So iron is a metal, and like most metals, it's actually pretty stable. It can just exist on its own. So I don't need to do anything special. I don't have to have this in a chemical compound. You can have just pure iron, no problem. What we are going to be doing is a single displacement reaction. So the thing is, that iron is more reactive than copper is. So what happens when I put these things together is the iron can actually kick copper out of its spot. And that means that copper is going to be left all alone in my products. So at the end of this, I'm just going to have some copper by itself. And the iron is going to sort of take copper's place and bond with the sulfate. This is sort of the Mr. Steal Your Girl of chemical reactions. Iron is coming in and it is stealing copper's partner, taking its place, leaving copper alone forever. The generic form of this kind of reaction, this is called a single displacement reaction. It's called a single displacement reaction because one single thing gets displaced, and it is a chemical reaction. So in this example, it is iron that is displacing copper. The sort of generic form of this chemical reaction is AB, so some sort of ionic compound, plus C, some sort of thing that's by itself, becomes CB, a new ionic compound, plus A. So we're going to end up with a different thing lonely at the end of this. Now, fun fact about chemical reactions work much better in liquid form than in solid. If I were to just mix the iron with the copper sulfate, not much is going to happen like that. So I want to take this copper sulfate and put it into liquid form, and to do that, I'm going to add it to this beaker of water. So I'm just going to dump that in, and I'm going to give it a little stir. Make sure I dissolve all that powder down at the bottom. And you can see this turns a lovely shade of blue. Compounds made from copper oftentimes have this really gorgeous blue, almost turquoise color. I've been told it looks like Gatorade, though as with anything in a chemistry classroom, you should never drink it. And what we're going to do with this is I am just going to take my piece of iron, and I'm going to stick it in this beaker, and we're going to let it sit there for a few hours, and we will see what this looks like eventually. So I'm just going to stick this in, and yeah, we'll give it some time. So I will return to this later on, and you will see what ended up happening in this beaker. All right, so it has been about 10 minutes, and I want to show you some of the changes we have here. So the first thing I want you to notice is that the color of the solution has changed. There's a lot less blue in it. The reason for that is because there is a lot less copper in this solution, and there's a lot more iron. Iron sulfate has kind of a yellowish color, so we haven't gotten rid of all of the copper sulfate. So there is still some of that blue color in there. But there's now also some iron sulfate, which has that yellowish color, so that blue plus the yellow ends up with this green color. And the second thing I want to show you is at the very bottom of this, it's a little bit hard to see, there is this red stuff. There's no more steel wool in there. It's been entirely dissolved. So the steel wool has been completely eaten away. But now at the bottom there is this reddish brown sort of precipitate is the word, this stuff that has come out of the solution and fallen down to the bottom, and that is actually pure copper, which came out of the copper sulfate because it was pushed out by the iron. So that is an example of a single displacement reaction. So we started with copper sulfate and iron, and now all of the iron is gone, and we have created iron sulfate instead, and we are now left with pure copper. So this again is an example of that single displacement reaction.